All right, so before we get started with the presentation, what you want to make sure you have set up is the collections package is in there, the testing.collections package with a file called collections test, which will be the test we'll run for this unit. Collections test will just have a constructor, and also make sure you edit your tester class to now run that unit test when we get started, okay? All right, so let's take a look at this concept of collections, okay? So obviously, if you think about just the word itself, collections, we're talking about a group of stuff, okay? So right away you might be thinking, oh, it's sort of like arrays, and you'd be right. That's kind of what it is about. But let me step back for a second and sort of examine what I mean by this concept. Okay, so you're now in your last year of computer science here at high school, unless you do the IB grade 12, and you're going to look, you hopefully are now looking at programming concepts in a new, more advanced way, okay? So for example, just recursion alone is a way you can look at problems instead of looping. So recursion versus looping is what a grade 12 computer science student can look at versus a grade 11 or grade 10 student would just have the only option of using looping. Even if we look at software in a bigger picture, we think of an app or software. When you first start learning about software, you think, okay, well, software needs to remember stuff, so there's memory, and software needs to control stuff. It needs to be able to execute instructions. So there's data storage, and then there's logic in an app. And when you first started learning, you were like, okay, well, conditional statements and loops, that helps me control it. And to remember stuff, I'll just use variables. And that's what you'd learn in grade 10. By grade 11, you'd also know, well, actually, I can also write these things called methods that help me control it. And for memory, I can use something a little more advanced, like an array, to store data. Now you're more at a grade 11 level. But even more so by grade 11, you finally learned about something called classes, which combine these two concepts together. So within a class, you can build both methods and properties to both have memory and control together. Now moving into grade 12, you now have more advanced classes that you can work with. That was the unit we just finished. And you also now are starting to use the word data structure rather than just the word variable to more accurately describe things. So like your classes are more of a structure of data. Now in the last unit we also talked about memory. And I said, well, when you first learn about something like an integer, this is good enough to remember what it conceptually looks like. But in the last unit I said, no, wait a minute, there's more to it than that. There's the contents of the variable and the identifier name, and there's a reference from one to the other. That's what the memory actually does, okay? So this is not something you'd look at with a grade 10 mindset. This is a grade 12 mindset at looking at memory, okay? Even in the problem solving you did, when you first learned in grade 10, you solved it sort of line by line problem solving. Remember, like dot visible equals true, dot text equals hello. It was very line by line. Now you're even thinking of things abstractly. That was a concept in our last unit. So you're now moving towards more object-oriented programming. You don't think of things line by line anymore, hopefully. You're really seeing the big picture as you're programming. Even diagrams have evolved. So I want to show you an example of that. Here's a diagram from grade 10. You may remember it from our first unit in grade 10, how to get a job. And I said this is something called a top-down design. And at the time it just seemed like a kind of a fluff, maybe assignment that you were doing in the grade 10. But by grade 11, I was using some version of that to help you to solve certain problems. Like this is an example of that roll dice program, and it was kind of a flow chart and kind of a top-down chart together. There was arrows in there. But now, even in our last unit, you are seeing things like these UML diagrams to explain the relationships between classes. So this is again an evolution over the 3 years of the way you've approached problem solving, from a diagram to a memory to a code sort of standpoint. Of course the code has changed. So in this unit, we're going to focus on data storage. From moving from variables up to arrays, the problem with arrays is they're always a fixed size. So if you want to change the size of your array, you have to rebuild the whole array. Okay? This limits the amount of data that an array can store. Now, you can set it to a large limit, but then you're also wasting memory of unused locations within the array. What would be better is a data structure that changes as necessary. So it will grow when it needs to get bigger, and it'll shrink when it needs to get smaller. This is known as a dynamic change. Dynamic meaning changing on the fly. Variables variables and arrays are known as static structures. They don't change on the fly. They lock their size in when you first create them. So our goal is to create a dynamic data structure. Okay? So that's what we're going to do. And we're going to combine it with the fact that we know about classes and put methods in it to make it useful to you. So it's something you can reuse. Okay? But we also in the last unit learned about abstraction. What does this thing need to do versus how it needs to do it? We also learned about things like interfaces and how we could use that. We also learned about things called abstract concepts and even the concept of generics, that it could deal with anything. So if we can incorporate that into this data structure, now we can make one data structure that will grow and shrink dynamically and store whatever we want. That's the goal. So you sometimes hear this acronym in programming, ADT. Generally, it stands for abstract data type, which is what we're talking about. It's a data type that is abstract, but I would actually replace the D with dynamic. So it's a dynamic data type. So it has that idea that it can kind of grow and shrink. Okay? So within this category of ADTs, there are several programming constructs that are used. The one we're going to build is the list, or specifically known as the linked list. But there's also other ones. There's the stack object, the queue object. If you take the grade 12 IB course, you'll learn those. There's the set, which includes the table. There's a graph. There's more than that as well. I don't have time to teach you all of them, but in this unit we're going to focus on the linked list because they all build from that one. Okay? Okay, so that's the concept we're going to do. We're going to do this thing called a linked list. Okay, so before I introduce it to you, can you tell me what you think? Again, forget computer science. Let's take those two words and break them down. So let's start with list in the back end. What is a list? Like a grocery list. That's an example. Okay. Stuff. Bunch. Okay. So it's a group, right? It's a group of things. Okay. So let's imagine it's a grocery list. Okay. So what are we going to buy? Give me some stuff you'd buy at the grocery store. Milk, eggs, sugar, bread. Okay. Good enough. You got it. Okay, so I'm just going to highlight these things. So you're going to have milk, eggs, sugar, and bread. Okay? Right now, are they in a list, would you say?
No, they got to be like that.
Well, they don't have to be vertical, but okay, so we'll put them vertical. Okay, so hang on. I knew that was going to happen. I knew it wasn't going to be nice to me and let me just do it like that. So I'm going to ungroup it. Okay, so here we go. Bread, sugar, eggs, and milk. And you guys say they have to go like this for it to be a list. Okay, does it have to be that way? Has to be alphabetical. Wow, you guys are really picky about this. Okay, so before we do anything more with this list, now let's talk about the first word. What does this mean? Forget computer science, what does that word mean? Attached. Okay, don't use the word to define the word. It's like saying, how do you define happy? Well, you're in a state of happiness. No, you can't do that. So what else would describe the word linked? Help me define it. Attached, joined. Okay, maybe use an example. What other connected? Yeah. Okay, give me an example like you guys with grocery. Give me something else that's linked. A chain, yeah. Okay, well what else? Give me another example of something that's linked. Web pages, sure, web pages. Okay, you guys are awesome. You got everything. Okay, So now let's take our list. How do we link it? Ah, do I link milk to every one of those? Ooh, so that's a simpler way. We could do it your way. We could link milk to everything, but what if I just drew a blue line that linked milk to eggs? Okay, and then I'll draw another blue line that'll link eggs to sugar. And then another blue line that links sugar to bread. Now, I don't have it in the style you guys asked for. It's back down here now, but could you handle that? Now, if I said to you, read me the list, would you say milk, eggs, sugar, bread, or would you say bread, sugar, eggs, milk?
No, it doesn't matter. Milk, eggs, sugar, bread.
Okay. Well, should it matter?
No. Well, I mean, it's sideways, so you can read it.
Yeah, but that's based on your training in English class. If you didn't have that training, could you go the other way? Could we at least help make it so that it is more clear? In our diagram, at least. What if, I'm going to propose something, what if I did this? Put arrowheads. Does that make it more, now would it be easier to say, oh, milk, egg, sugar, bread, like it actually seems like it has a direction? Yeah. You guys have basically just done the whole unit. You understand what's going on here. This is essentially what a linked list is. Now, the list could be literally anything. Like we happen to use grocery items, we could have used numbers. We could have used stuff from our last unit. We could have used athletes to connect it together. That's the idea with the linked list. It is something that's interconnected from one thing to the next. Okay, so we're almost done. Let me just finish up some of that theory. So a linked list is a collection of data objects linked together. What a surprise. Where each object maintains a reference. Ah, there's a word from memory in the last unit. Remember reference? Or a pointer. Ah, that's why I drew a point. To the next object in the list. This is different than an array. So you may remember when I talked about arrays, the identifier name referenced a bunch of content. This is a little different than that. It's basically you have an identifier and an object referencing another object of the same class. Now let me pause there and process those words. This is known as a self-referencing object. So it's an object that makes a reference to another object of the same class. Okay? So that's a little tricky to grasp, so you'll see how that comes together when we do the example. Okay, so don't focus on that too much right now. So each spot is connected like a chain to the next spot in the list. We can use the spots to store information, store data. And we can have multiple data items, so we can add and remove spots from the chain. Okay. So let's actually think about that for a second. Let's go back to our diagram. If I want to remove sugar from the list, what would I do? Okay, so yeah, you're right. I take it out. But now what? Ah!
Eggs references bread.
Right, so now this can move into that spot. And then I'd want to remove the arrow. Okay? Wait, I want to add sugar back to my list. What do I do? Where?
After bread.
After bread? So I'd put it here, and I'd put this down here. You guys know this really well before we even start. You know the concept of what we're about to do. You got it. Okay. So if we combine this with abstraction and things like generics, we can make a linked list hold literally anything. That's good. Okay. So for example, we'll have a spot where we can store data, and then a connection to the next item in the list. That's the way we can visualize it. And linked list is a lot about visualization. Okay? It will create a structure like this one where one will be chained to the next. Okay? Now, what is this last one chained to? It's chained to nothing. Okay, what would be a word that could describe nothing in code?
Void. No.
Void. Yeah, that's one way. What's another way? Null. Yeah, null is a great one. So we have words in code that can describe things like nothing. Okay, so the linked list, as I said, is helpful to be drawn. As I said, the last reference will be a null. Usually when drawn, it will be drawn with a slash. So you're going to see the most common way linked lists are drawn. And chances are, if you study computer science at the university level, this is how you'll be taught as well. So this is a linked list of integers right here. Okay? The description of each spot in the list uses the word node. Node is the term that's used to describe each spot within the list. And the last list item references a null, which is usually drawn as just a slash. Okay? And we don't draw lines, we generally draw arrows to indicate a direction for this list. The entire thing is called the linked list.